All right, 7.6 in your Red Stewart textbook here. We're going to talk about the derivatives of inverse trig functions, okay? So we've talked about what inverse trig functions are. That's the the sine to, so let's say sine to the -1 of x. That's an inverse trig function, right? We've got cos to the -1 of x, and we've got tan to the -1 of x. So what is the derivative, right? Dy dx. What's the derivative of this function? Well, that's what we're going to explore today. So how I'm going to do that is I'm going to show you, okay, I'm going to lead you to this point. So let's start off with, and this is a derivation, so this is like how these derivatives are arrived at. I'm going to show you one example to set up this lesson. So if we start with y equals sine x, I realize that the equation of the inverse is when I do what to the variables? Inverse means what? Yeah, inverse means reverse. So guess what? I'm going to actually do this. So now this is the original function right here, original. And this right here now is the inverse function. You got that? Okay with that? So let's go from here. Okay, well, we'll go from here. So if I take the derivative of both sides here, so d with respect to x, d with respect to x, I get 1 over here equals, now this is going to have to be a chain rule, right? Inside function, outside function. So the derivative of sine is cos. You leave the y in there. But then because y is not x, you do have to multiply by the derivative of y. And of course, if we're trying to find d dx, that's actually the same as y. Now, I should have maybe, sorry, I will dy, I'll keep my notation consistent here. Okay? So dy dx is now 1 over cos y. Okay? I'm dividing both sides by cos y. So that's the derivative of this inverse function. But I'm not really happy with that because I want it with respect to x. So we want to figure out what this cos y is with respect to x. I don't want y in there. So where do I go from there? Well, from here, you think about, cos squared y. Cos squared, well, this is what you're familiar with. Cos squared x plus sine squared x equals 1, right? You remember that? Or sine squared plus cos squared equals 1. Okay, so we know that. Now, if I want to solve for cos, and I'm going to change this to y just for this example. Okay, it doesn't really matter. But I'm going to change it to y over here. Now, I'm going to try and find out what cos y really is here. Like, really, what does it mean? What is that? So I'm going to try and isolate for cos y here. So I'm going to go cos squared y equals 1 minus sine squared y. Okay. I'm going to take the square root of both sides to find what cos y is. Okay, I cannot get rid of this squared by taking the square root, right? I have to take the square root of the whole side. Not as simple. So we're close, except I still have a y over here, so guess what? If you go back to the beginning, so where I started before I put these derivative signs in here, yeah, sine of y actually just equals x. So sine of y equals x, so that means I'm going to rewrite this as cos of y equals the square root of 1 minus x squared. Okay, so that's what cos y is. And now, to express my derivative of this inverse function, I can actually write this as 1 over root 1 minus x squared. Okay, so what does that all mean? Well, let's just summarize that. So sine to the -1 of x, okay, if you have that, then the derivative is 1 over root 1 minus x squared. And remember, this right here, sine to the -1 of x, can also be written as arcsine of x, right? ASN x, whatever. So here we have what arcsine is, the derivative of this. Okay, so we should say d dx here of the arcsine. Yeah, derivative. So don't worry about this side right here. We don't have to worry about these for this course here right now. But, and this is probably one of the most awkward charts I could find. Sorry, that's a root sign there. Okay. Oh. Yeah, it is still frozen, sorry. Okay, so here is the chart that you can write down. I'm not going to derive all of these ones, but arc sine, derivative of arc sine is 1 over root 1 minus x squared. And that's going to be our format. So just go ahead and take a minute to write that down. These. Okay, so what this means is that if we have, if we want to find the derivative of an inverse trig function, I can use these as forms, right? Just basic formats. All right, so let's take a look at something like this. Go ahead and write that down. All right, so let's take a look at this one here. Now, this is not just sine to the negative 1 of x, or arc sine of x. It's arc sine of 1 minus x squared, okay? Or sine to the negative 1 of another function. So if we're taking the derivative, we do have to remember chain rule, okay? Chain rule. So we have to remember that at the end, we're going to have to multiply by the derivative of this. So let's take a look. Well, I know that the format of this right here, okay, so dy dx, take the derivative of this. The format is 1 over root 1 over root, and look back to your chart. What did we just work out here? 1 minus x squared. See that? So the x is whatever this sign is of. So it's 1 minus this, 1 minus x squared, times the derivative of 1 minus x squared. Because we have to do chain rule, so that's negative 2x. Okay, so that's the first step of differentiation. We've used the form, right? The derivative of this is this right here. That's great. Because this right here is not just x, I have to do chain rule and multiply by its derivative. Okay, we good so far? All right, so let's simplify this now. Dy dx is, the top is just going to be negative 2x. On the bottom, let's multiply and gather like terms underneath here. Because this is not how this is going to end up. It's going to be 1 minus, okay, and we're going to have 1 minus 2x squared plus x to the 4th there, it looks like. Okay? All right, so if we gather like terms underneath the root sign at the bottom, we have dy dx equals 2x on top. I have root, well, 1 minus 1, those cancel out. I have plus 2x squared, minus x to the 4th.
Will that be 1 plus 1?
Nope, it's 1 minus a positive 1. And then we have minus a negative 2x squared and minus a positive x. That's how you get this. All right, now we can factor the bottom, so we're going to do that. Let's factor this, simplify it a bit more. This is going to be root x squared times 2 minus x squared. And you may be thinking, hey, can I actually bring this x squared out of the radical, out of the square root? You can. You can. You can. And it's going to actually be, it's going to be a negative 2, and it's going to be plus or minus x root 2 minus x squared. Okay? Another way to write that, and I'm going to show you this here now. Another way to write that plus or minus x is absolute value of x. So when you have an x squared and you have the square root of an x squared, it could be positive x or minus x. This is another way to write this. And this represents two different versions. So I like this a lot because you can see that there's two different versions of this answer. Okay? And I will just, that didn't sound good. Something fell over pretty hardcore. Okay. So do you see how these are the two versions of the answer? We have a positive x, or Looks like something is missing here. Oh, no. I've simplified. So this was x here, and those are now gone, right?
Well, we'd be happy to simplify.
Yep.
further.
Yeah, you have to simplify things, yep. And this was a negative 2x over a, I guess this would be a positive x. This one would have been the negative x here, because, yeah, that was a negative. So that's this and they're gone. And that's this and they're gone. Now, not only will you have to simplify sometimes, for sure, but you're also going to have to also examine what's the domain for this kind of thing. Like where does this show up and where does this show up? Like why is it like, when is it like this and when is it like this? Well, again, if we go back to the way this was like this. So the absolute value of x, when x is actually less than 0, right, then the absolute value of x really is equal to negative x. So in this plus or minus x, x is minus x when x is less than 0. So this is when x is less than 0. That's what the graph looks like. And this again is the simplified form. When x is less than 0. Over here, remember this was like this before. So when x is greater than 0, right here, positive x down here, this simplifies to the negative version here. All right? So two things you want to make sure you pull out of this is that if you have this situation where you take the square root of x squared, that's going to be a plus or minus x, also written as absolute value of x, which means that it is, when x is less than 0, this is actually meaning the negative x. When x is greater than 0, this actually means the positive version of the x. X is positive, x is positive. So that's how you separate the domain for each of these. Okay? That won't be super important right now, I don't think, but that is something that you'll have to eventually take care of. Questions?
Yeah.
So attempt that one on your own and take a few minutes and see if you can get that. Here. Okay, so I guess the format here, right, is the derivative of cos to the negative 1 is negative 1, we'll go back up here, negative 1 over root 1 minus x squared. So it's very similar to sine, arc sine, but you have a negative. So that's where this comes from, negative 1 over root 1 minus, and this right here goes inside, right there, root 2x minus 1, and then that is squared. And because this is not just x, if you do chain rule, so the derivative of, and this is again, remember this is 2x minus 1 to the power of 1/2, so you bring the 1/2 down, subtract 1, multiply again by the derivative. So what that does is the 1/2 and the 2 cancel out. This right here comes down to the denominator as root 2x minus 1. So that negative 1/2 becomes a positive 1/2 if you bring it down to the denominator. Okay, so over here now, if you were to actually square this root, the square and the root cancel off, so you just get 1 minus 2x minus 1. So you're left with this, which turns into a 1 plus 1 is 2 minus 2x. So root 2 minus 2x times root 2x minus 1. Now, over here, Devine said that, well, I rationalized the denominator. Well, you didn't really rationalize the denominator. You got rid of this radical, but you put a radical on top. So if you have a radical on the bottom and not the top, and then you put a radical on the top as well, you're making it less simplified. So you kind of want to deal with just these radicals down here, and what you can do is multiply them together, right? So what I did was you have a root something times root something, you just multiply those together. And I factored a 2 out of here. So this is 2 times 1 minus x. Okay. So where are we from there? Well, we're pretty close. Could you leave it like that? You could probably get away with leaving it like that, I would say, yeah. Yeah, because I multiplied this out here and then, well, I don't know why I did this, because it ended up factoring it again. So you really could, I think that 2x minus 1, 2 minus 2x, yeah. So really you could stop, I could have stopped right here. I think maybe I did that before because someone asked about something. But yeah, you could stop right here because this is factored. There's a radical only in one numerator or denominator only in one. And so this would be your final answer right here, which matches up with what you see in the solution manual. Except I've factored it a bit further. So I see there's a common 2 here, common factor, so that's what I did. Okay? And if you went ahead and multiply, if you had a root in the top and the bottom, well, you look in the solution manual and you see this, and you're like, well, I don't know if I got it right or not. So you might have to just manipulate your answer just to see if it matches up with the same as the text somehow. Question? Okay, so let's go back over this again. With the tan, the form is 1 over 1 plus x squared. And because this is just an x here, I don't have to multiply by a chain rule really. Plus the derivative of this is 1 over 1 plus, and then whatever this is, right? 1 over x squared. I do have to multiply this by the chain rule, so I have the multiply by the derivative of 1 over x, which is minus 1 over x squared. From there, I want to simplify this. So a negative turns this positive into this plus into a minus. And then this is in the denominator, so this x squared gets multiplied by 1 plus 1 over x squared. And when I do this part highlighted in yellow, I get x squared plus x squared over x squared, which is 1. Because of the commutability of addition, if you have 1 plus x squared, it's the exact same as x squared plus 1. So I have a value, as a certain quantity, minus itself. Answer is 0. Okay, so that's the solution to m there. I don't know if that's 1m maybe.
Mahan, please come to the main office. Mahan, please come to the main office.
So, that's 7, sorry. Yeah, that's 1m. All right. So I won't do this one with you this lesson. This one's a bit of a longer one. We don't have the time. Shortened class here today. That's part of the answer for that one. So we won't do that monster. But I will, let's just show you your assignment. So check the website, mrmathwell.com. Here's your assignment here, 7.6. 7.5 you did yesterday, and that's not ACA, that's ACE for some reason. It's a bit of a typo. I'll fix that. Alrighty. Okay, so go ahead and work on that tomorrow. You are dismissed.